two functions, what can you do with that integral?
Split it up.
You can split it up, exactly. Okay. So now we know that f of x, g of x, is equal to the integral of f of x, g prime of x, dx, plus the integral of g of x, f prime of x, dx. Are we okay with that? We haven't really done anything too deep here. All we've done is taken a derivative and kind of gone backwards a little bit. Honestly, if you first time you see this, which is hopefully now, well maybe now, it looks worse than what we started with, right? I mean, to me it looks worse. So what I'm going to do now is I'm just going to move this one over to the other side arbitrarily, okay? So now I'm going to get f of x, g of x, minus the integral of g of x, f prime of x dx equals the integral of f of x, g prime of x dx. So all we've really done is play around with the product rule. We differentiated, we integrated, we moved some stuff around. And the way you traditionally see this written, though, is you see, I'm just going to switch the equal signs here. You usually see it as the integral of f of x, g prime of x, without the extra parenthesis right there, is equal to f of x, g of x, oh, there's no dx there, minus g of x, f prime of x, dx. So this is what you are going to work with, and I'm going to show you why it's useful so that you can actually believe me and see that it's useful. It's actually not that hard to remember this, because all you have to remember is you're taking the integral of two functions where one of them is stated as a derivative. So this is usually u v prime, is what they're going to call it in the book. And then you have u times, but not v prime, what does it become right here? V. So we have u v prime equal, the integral of equals u times v minus v du. Okay. There are certain specific instances, there are certain very specific instances where you run into what seemingly is totally unintegrable. You run into a wall very, very quickly. Have it. The second way you usually see it is the integral of u times v u times v prime, excuse me, u times v prime equals u times v minus the integral of v times, yeah, so we usually write it as dv, and this is du. The only reason I think they like writing it this way, why do you think people like writing it that way? It's the same thing, but why is it preferred, why is it written that way, do you think? Less parentheses is shorter. What's one poor choice? Why is u and v a poor choice of variables? They look kind of the same. So once again, mathematicians choose variables poorly sometimes. So there's nothing to do about it. You're just going to see a whole lot of it. So how do we use this? Well, what's u? We want u times v. What's u times v going to be?
X sin x.
X sine x minus, what's v?
Sin x.
Sine x. And what's du?
Dx.
Dx. Okay, so now we've turned this into this. But what's a problem?
We don't. You have to have udv in the first one.
udv in the first one. No, we don't. This is, I'm sorry, I was not clear. This right here is, what is that?
U.
That is u. And,
That.
oh, I see, our setup. I'm sorry, I totally understand what you're saying. No, I totally understand what you're saying. So we chose an invalid choice. We need to choose u and dv. You're absolutely right. Okay,
That's
so
why I was saying you should probably be
no. You're absolutely right. Yep. We substituted wrong. It's fine. So our initial choices didn't work because we couldn't actually use them.
Right.
Great. Congratulations. We're awesome. So again, what do we want x to be? Oh, sorry, u to be?
Actually, you should probably be sin x so that we don't get a negative on the side.
I understand. What I'm trying to do, everybody, is I'm trying to show the wrong ways first to get up to against walls, and then we'll try to go around them once we realize what the issues are, okay? So u is equal to x. What do we want dv to be equal to?
Sin x.
Sin x. So sin x dx, thank you. So what is du going to be equal to? Dx. And what does v going to be equal to? Negative cosine x. So now can we write it properly? Sure. This is going to equal the integral, as our problem was before. It should theoretically now be solved. We now have u and dv. Does u and dv multiply together to get the proper thing? So this is u dv. And what is that going to be equal to? X times negative cosine x minus what? the integral of what?
So
V du. V du.
cosine x
Negative cosine x
dx.
dx. So that's equal to negative x cosine x plus the integral of dx. Is the integral of cosine x something that we know? What is it? Yeah, so negative x cosine x plus what? Plus c. How do we check to see if that's the proper integral? Find the derivative and see if it is. So let's actually check that right now. So the derivative of the first times the second plus the first times the derivative of the second, which is negative sine x, like this, plus what? Cosine x plus 0. What happens here? And you're left with? Did it work? It did. So again, the challenge is going to be choosing proper u and v values. U and v values. And in this case, u and dv values, because you need to construct the function first. You need to construct the function first. You can go u of v, you just have to make sure they multiply together to get the function you actually want it to be, or it's totally going to fall apart, as we found out. So, are there, we're dictated kind of what we need to build, but are there other choices we could have made theoretically? Sure, we could have switched it around. Sometimes that will be okay, and sometimes when you do it, what will happen is in your attempt to create an integral that you can actually integrate, this will turn out to be just as bad as the original integral. If you end up with the same one or something that's worse, your choices for u and dv are probably not the greatest one. Are there sometimes multiple options? Yes. Are there always? No, not always. So we really only have two different options here. We really only have, because ln x dx, there's only two things being multiplied together. So what do you want u to be? Any guesses? There's only two things multiplied together, ln x and dx. What do you want? Ln x. Good choice. And what do we want dv to be? Dx. If that's the case, what is du? 1 over x. And what is 1 over x? Thank you. That's fine. Dx. And what is dv, the integral, going to be? What is v going to be equal to? X. Exactly. Very good. So now, first, let's check this. Is this equal to u dv? Yes. So now, what was it? It was u times v, so it's going to be ln x times what? X minus the integral of, let's go back up, what was it? Do you remember? V du. It's the opposite. So what is it going to be? X times, what's du? 1 over x dx. But what's 1 over x dx equal to? So we have x ln x minus the integral of what? 1 dx. If we integrate that, what do you end up with? X ln x minus what? Plus c. How do we check to see if that's correct? Not integrate, we want to differentiate. So if we actually spend time differentiating this, we get the derivative of the first times the second plus the... What? Are you interrupting me, or let's check it and see if it's right? The derivative of the first times the second, thank you, got it, plus the first times the... I did the derivative of both, didn't I? Got it, okay. And look what happens. What's x times... What's that?
1.
Yay, it's gone, and what are you left with? Is that pretty cool? It's relatively neat. Again, though, it's only going to work in specific circumstances. You're going to have tools, you're going to have u substitution, you're going to have integration by parts. Are they always going to work? No. No, they're not. What do you want u to be?
E to the t.
You want u to be e to the t? Okay. And what do we want dv to be then? T squared.
Could I switch?
Okay. You want to switch it? Okay. So what do you want u to be?
U should be t squared.
T squared. Okay.
Yeah.
And dv is going to be what?
E to the t dt.
E to the t dt, which makes v what? E to the t. That kind of is nice. And what's du going to be?
du is going to be t, 2t.
2t what?
dt.
dt. Okay, so first of all, does it check out? T squared times e, yep, it does. So now we need to do u times v, which is going to be what? T squared. So this is u times v, e to the t, minus the integral of, what was it, v du?
Yeah.
So the integral of e to the t
times 2t dt.
times 2t dt. What can you pull out of the front of that integral?
2
So you have t squared e to the t minus 2 times what?
e to the
T times e to the t dt.
Mhm.
You're like, huh, how do I integrate that thing?
Well, do it again, yeah.
Do it again. Very good. Very, very good. So what's u going to be this time?
T.
T? Okay. So what's that going to make? dv.
dv is going to be
E to t dt. So that makes
nice one to have.
v is equal to e to the t.
Yeah.
And du is going to be equal to
I mean,
dt. Right. So now we do it again. We end up with t squared e to the t minus, what does this end up becoming? U times v.
Multiplied by 2.
2, thank you. T times what?
E
T e to the t minus the integral of,
to the t dt.
and what's e to the t times, well, so v du, so dt, yep. Mm-hmm. So what do you end up with? You get t squared, oh, look at this. So you get t squared e to the t minus 2t e to the t plus what?
2e to the t.
Plus 2e to the t plus c. Plus c. Now, yeah, is there anything in there that we can simplify? What do you think? Remember the basic u substitutions where you could kind of do them in your head? What was the danger in doing the really easy u substitutions in your head? You'd mess up. It's really easy to forget something, right?
Like forget
The one, yeah, the 1/2 that needs to float out front, right? It's really easy to forget it. It's really easy to confuse what you're multiplying together here. What kinds of, yeah. So I have a question for you. So the trick really is choosing the proper u in dv to begin with. What are you doing to dv? You're integrating it.
Yeah.
What are you doing to u? You are differentiating it,
Yeah.
right? Generally speaking, which is harder to do, integrating or differentiate?
Integrate.
Generally speaking, integration can be a lot. So take the one that's easier to integrate and make that dv, because you know you're going to have to integrate it. You don't want to pick something nasty for this because you don't want to create more work for yourself. You're trying to make it easier on yourself.
That's why I was
Yeah.
like really good.
So let's have a vote here. What should we make u equal to? You want u equals sine x? Good choice. I like sine x. So what's v going to be then?
E to the x, yeah.
Yeah, you really like that because now...
No, dv.
dv, thank you. You now know that v is equal to what?
E to the x.
E to the x. Happy time. And du is equal to?
No, positive cosine x.
Who said negative out there? I don't want votes for negative. Cosine x. So the checking works.
Yes.
Thank you.
Sorry.
No, it's okay. It's okay. It's good that we have someone to do that because it's important. So what do we end up with? We need uv minus the integral of v du. Again, don't know why they chose u and v. So what do we end up with?
You get
E to the x sine x minus the integral of e to the x times what?
cosine x dx.
Cosine x dx. Okay, that's kind of nice-ish. It's kind of nice-ish. But what do you notice? Where are we now? Where are we?
You've moved nowhere.
We've essentially moved nowhere, right? Because now we need to integrate something that is functionally identical to
Do it again,
this.
and then you can do magic.
I know, there might be magic. There might be magic.
You-
This makes me nervous because you're back similar, you're kind of where you started, right? Do you agree?
Yes.
Let's just do it one more time just to make sure nothing cool happens. Something cool might happen. Okay, so what do we want u to be? Cosine x. So dv is
E to the x.
dx.
Dx.
So v is equal to?
E to the x.
Mm-hmm. du
No,
negative
sine x.
sine x dx. So now what do we end up with? We have e to the x sine x, right? Minus what's going to go in here, the new thing. U times v, what is it? E to the x cosine x, correct?
Yeah.
Nice, okay. So then we have to subtract the integral of what? V du?
Which is negative
E to the x times what?
sine x dx.
Negative sine x dx. You see that right there?
Yeah.
Okay, so what is this? What was the original thing we were trying to set this? This is equal to what? What was the original thing that we set this equal to?
Oh, yeah,
The integral of what?
Sin
E to the x what?
Sin x
dx, right? So what can you actually do? What could you?
Well,
Well,
first off,
make it
bring the
positive.
negative out.
Yep.
And then distribute the negative. You get
Yep.
e to the x
So you get e to the x sine x minus e to the x cosine x
plus,
minus
minus
the integral of e to the x. It better be, or we're in trouble.
sin x, yeah.
Dx, thank you, equals the integral of e to the x sine x dx. What can you add to both sides?
E to the x sin.
Yeah, so you end up with the integral of integral of e to the x sine x dx is equal to what? E to the x times sine x minus cosine x. So the integral of e to the x sine x dx is equal to e to the x sine x minus cosine x all over 2.
It's a very good idea to remember that you have two sides of the equation.
Yes, it is very important because you know what? I will be honest with you. Unless you're really looking for this or have seen this kind of maneuver before, is it going to be easy to see?
No.
No. I would sit there going, man, I am stuck. Because then I'd get I'm like, oh, wait a minute. Look at that. You can add it over there and it becomes 2 of them. So you can get rid of 2 of them by dividing by 2. The magic of dividing by 2. You're going to be the guide here. So what's you going to be?
Tan negative first.
Tan inverse.
Inverse. Okay.
And what's dv going to be?
Dx.
Dx. So v is equal to?
X.
And du is equal to
1 over 1 plus x squared.
dx. So what is this therefore going to equal? X tan inverse
X.
minus,
Integral from.
and we got to go from,
0
yep,
to 1.
0 to 1. Right, exactly.
And
But then
from 0 to 1.
of what?
Of x over 1.
X times, yeah, 1 plus x squared dx. Yes, exactly. So now we could do the first part out here. When you plug in 1, what do you, you get, you get pi over 4 for this first part, and when you plug in 0, you get 0.
Yeah.
So you get minus. Now what do you have to use? What is u going to be?
1
Yeah, don't use integration by parts. It's like, man, got to be stuck. You can only, no, you can mix it up. So du is equal to 2,
2x.
dx is du over
2x.
2x.
Keep the 1/2.
Yeah. So what does it become from 1 to what? I'm substituting first. 1 to what?
2.
1 to 2. You can pop the 1/2 out, and you're left with x over u times du over x. What's the magical thing that happens? You love that going away, which is great. So now you have pi over 4 minus 1/2 integral from 1 to 2 of u to the du. So you have pi over 4 minus 1/2 of ln u from, so with pi over 4 minus 1/2 ln 2 minus ln of, which is 0, so end up with pi over 4 minus 1/2 ln 2, and you guys like adding fractions, so you can multiply by 2 over 2 and end up with pi minus 2 ln 2 all over 4. Sure, go right ahead. Totally fine.